Good morning, everyone. My name is Carl Walter. I'm the Emerging Markets and National Security Industry Manager here at Esri, and I'll be facilitating our discussion today. Our webinar is titled Getting Started with ArcGIS to Identify and Detect Patterns of Fraud, Waste, and Abuse. And our discussion will focus on a series of workflows specific to that, designed to show how GIS technology can support fraud investigations and analysis. We are scheduled for a full 60 minutes. We'll hopefully include time for a few questions at the end, and you can submit those questions through the online GoToMeeting software tool. If we don't get to your questions, we will respond to you directly through the email that you provided when you registered for the webinar. If you're interested in more specific information on how to deploy the Esri platform, there will be an option for you to request a specific follow-up, and we'll ensure that the proper Esri personnel reconnect with you directly and answer any questions you may have. So our agenda today is pretty simple. I'm going to introduce our other team members and presenters, and they'll go through a series of workflows, all of which depict analytical techniques to help understand and investigate fraud cases. So we'll start off with an introduction to Portal, and then we'll move into some more technical demonstrations and intro to Insights and displaying its feature functionality. And our example will be a redlining and analysis to support the identification of redlining. We will then do a deeper dive into analysis, where we will actually identify what I'll call outlier trends in the SNAP program, followed up by an investigative collaboration and modeling example, how to create, model, and share tradecraft. And we will be looking at the suspicious activity of a specific single physician, and we'll push that information out and the related information products out to a story map to show how ArcGIS can be used not just as an analytical platform, but as a communication platform. Presenting with me today will be Rob Fairstein. Rob is one of our National Law Enforcement Solutions engineers. Also supporting this webinar will be Patrick O'Brien, who is our Emerging Business Team Solutions engineer. Now, through these presentations, there will be no overlapping steel thread, other than that we will try to follow a methodology that mirrors existing open source adjudicated fraud cases. So we're not able to, nor are we going to try to 100% mimic what might be, a true investigative workflow for a variety of reasons to ensure confidentiality in some of the tradecraft, as well as we have limited access to some of the real data. So I do ask you to take that into account during our discussion, but more important, focus on the capabilities of the technology and how you might be able to apply it to your own specific situation. And all that being said, we think that the workflows that we are going to show will be pretty close. And we're going to follow kind of a standard, collection, analysis, dissemination, conversation here, but our focus is primarily going to be towards analysis and analytical capabilities, as well as pushing out the results of that analysis, the dissemination. And our two primary tools to show that to you today are going to be Insights and Story Maps. So why are we here today? The ability to show you all some unique, non-traditional analytical tradecraft and investigative workflows using spatial technology, using GIS. We do know that on the commercial side, on the government side, there are billions and billions of dollars to fraud and to waste and to abuse. And one of our examples today is going to focus on fraud and the opioid epidemic. So we know the damage that that fraud costs to our general government work, but when you link it to the opioid problem and to the addiction and to crime and border violence and whatnot, it's a much different story than some of the traditional fraud that we might all be familiar with. There's 59,000 people a year die to overdoses, and 2/3 of those are opioid related. And it's now the leading cause of death for Americans under 50. So fraud in this case takes a really, really different example. And we're going to get deeper into that in one of our workflows. So I'm now going to turn this over to Rob Fairstein, and Rob's going to actually walk through a quick technical review of Portal for ArcGIS. So as we're switching over to his screen, Portal for ArcGIS is the component of Enterprise that allows you to share maps, apps, and other geographic information within your agency and to vetted people within your agency. So I'm going to turn this over now to Rob, and he's going to explain Portal.
Thank you, Carl. Like Carl said, Portal is your organization's hosted or on-premise foundation for creating and sharing apps, content, analysis, mapping, and collaboration. And what you're going to see here today with the examples is the underlying technology supporting it all. When users come to your Portal's homepage for your organization, they're welcomed by information that's relevant and up to date that you want to communicate to your audience. And they can easily come here and interact with it via the carousel and open up these different maps and apps to explore and support their mission. The gallery feature allows the user to come in and browse your organization's content, which includes 2D maps, as well as web layers, 3D maps, to include also web, mobile, and desktop applications, different tools, and they can also add file types that aren't GIS, so PDFs, PowerPoint, images, and documents that might be relevant to their operations. One of the newer features that's been added to the gallery for organizations is to also link out and browse content from Living Atlas. So this is the GIS community's collaboration and sharing of thousands and thousands of different pieces of content that might be relevant to support their workflow or to expand their analysis. Using the content feature within the organization, the individual, once they've logged in, they can come in and they can view all of the different types of content they've created from desktop or add it to Portal. This can be the different web maps and apps, the layers. They can come in, they can filter and search. They can also add more content. They can browse from their computer, search for other web resources, create a link to an application. They can also create new GIS content like tile layers, maps, web scenes, or use the dozens and dozens of web application templates to create a new app. The map viewer within Portal is another way to take WebGIS and to interact with the different content that's been made available from the portal by searching for layers and adding those to the map. You can easily change the base map. And you can also conduct analysis right here in the web. Taking one of the pre-existing web maps that's already in our portal, I can also share that out and create an application. So here are those dozens of web application templates that I mentioned a minute ago. I can browse and easily select and begin creating these applications and share that to the organization once I'm ready to do so. The scene viewer here in the portal also allows you to look at 3D content. So here I'm able to easily interact and look at this different information that's available from one of the members of my group that has shared this content out to the organization. Probably one of the most powerful and exciting pieces about Portal is the collaboration element using groups. So here, looking at my groups, I have a group where one of my colleagues has invited me to look at some of the investigations and the work he's done supporting those. So here's all the different content. And then using the group feature, I've also created my own group for a project I'm working on. And now that I've created some content and added it in here, I want to invite my colleague Patrick to the group so he can begin looking at adding his materials for the effort. Now he has an invitation that's been sent out to him. And then once Patrick and I get to a point in our project where we believe the group or other people are ready to see in the organization, we can use the share function, and we can go ahead and share that out to more people in the organization so they can see what we're working on. And so this is Portal, and just a quick overview, and I'm going to pass it back over to Carl.
All right, Rob, great. And again, we just wanted to do a quick overview of what that of what Portal looks like and explain it kind of at a high level, how you manage your geographic content, how you manage your data, do analytics, and actually share that information with others in your organization. So our previous webinars went over WebGIS. We've gone over desktop analysis. What is a web map? What is a web app? If you've not seen those webinars, they are recorded, and we will make them available to you if you're interested in. We'll provide you that information with some follow-up emails. Again, as I said earlier, our focus on this webinar is going to be primarily analysis, and we're going to do that through what we think is a breakthrough tool, Insights for ArcGIS. And if you think of it, and we'll demonstrate, kind of as a light business intelligence tool that allows you to discover and interrogate your data in very, very new, different, and unique ways. Now, our examples are going to be pretty tactical and investigative in nature, and what we're not going to do today is tackle some of the big data questions, and we're going to leave that to subsequent webinars where we will present on geoanalytics or ArcGIS geoanalytics server. So for our first technical demonstration that Patrick is going to do, we're actually going to try to mirror a case that allegedly involved redlining by the Hudson City Savings Bank. So our example will be similar, using sample data that'll show some interesting ways that whether you're an investigator, an auditor, an analyst, you can better understand and identify trends in your data, which what I would argue would be invisible if you were not using GIS as one of your investigative tools. So I'll turn it now over to Patrick O'Brien, who will talk about identifying illegal redlining activity. Okay, Patrick.
Okay, thank you, Carl. So as Carl mentioned, this is the third progression of our GIS for fraud, waste, and abuse webinars. Here we are introducing ArcGIS, or Insights for ArcGIS, to our fraud, waste, and abuse workflows. Insights for ArcGIS is a new paradigm in analysis for the ArcGIS platform. It blends BI-like capabilities with spatial analytics using intuitive models so you can concentrate on discovering the stories that your data is trying to tell you. Insights for ArcGIS is a new application within the ArcGIS technology stack. It supports a new pattern for analysis and visualization. It is designed to give you fast, dynamic, and powerful data exploration and discovery. It allows you to drive impactful decisions, learn about your data, and share and collaborate with your organization. Insights also allows you to connect to a variety of different sources and formats of data. So you can create direct connection to databases such as SQL Server, SAP HANA, Teradata, and Oracle databases. You can also import your Excel spreadsheets, and obviously connect to your complete ArcGIS content that Rob just went over. Now, Insights is about analysis. Although similar, it's not technically a dashboard or a report. It can be used as such, but Insights is really designed to go beyond dashboards and reports and enable analysis to be completed in one central location. So today, for our first demonstration, what we're going to be talking about is redlining within financial institutions. So as Carl mentioned, redlining is the illegal activity of denying services either directly or through selectively raising prices for areas based on variables such as demographic variables and socioeconomic variables. So as a result, this illegal practice gives these communities less opportunity to the services they need. An example of this fraudulent redlining practice, as Carl mentioned, is the alleged case against Hudson City Savings Bank. The Consumer Financial Protection Bureau and the Department of Justice announced a joint action against Hudson City for discriminatory redlining practices that denied residents in majority Black and Hispanic neighborhoods fair access to mortgage loans. So the joint action alleges that Hudson City illegally avoided and discouraged consumers in these neighborhoods from applying to credit by 1, denying services in these areas, 2, avoiding locating branches and loan officers in these communities, and also 3, excluding them from its marketing strategy. So what I want to do is I want to show you the basic feature functionality of Insights for ArcGIS. So I want to connect to various data and allow my data to tell me a story. So while we're doing that, let's take a look of a theoretical example of how Insights can be used in examination of a banking institution, potentially redlining in Washington, D.C. So what I'm going to do now is I'm going to sit in the role of a financial regulator to monitor the services provided by this theoretical bank. So once I open Insights, as you can see here, Insights is available as a web application. So what we're seeing here is we're seeing multiple workbooks. All of these workbooks are workbooks that have been created by me or workbooks that have been created with people within my organization that have been shared to me that I have access to. So what I'm going to do is I'm going to create a new workbook. And as you can see here, it gives me a blank page. So this is the idea of pages within workbooks. So now what I need to do is I need to connect to my data. We do that simply by clicking Add Data. And now I can connect to the various sources of data that are available to me. I can connect directly to my databases, bring in Excel or CSV files, and also connect to my ArcGIS content. So when looking at this possibly fraudulent redlining activity, I have some information out there that's available to me. One of those is the bank locations. So that's something that would be interesting to me when doing this analysis as a financial regulator. Another thing that I might want to look at, since we're looking at a very small area in DC, I also want to get to know the demographic and socioeconomic variables. So I'm going to use the Living Atlas layers, which, as Rob mentioned, is this authoritative collection of global geographic information that we have made available to you. So I'm going to bring in census tract areas. And I've also received an Excel spreadsheet of information. So all I'm going to do is I'm going to take this spreadsheet and drag it and drop it in this location and click Add Data. Now, once I click Add Data, you can see that Insights has already located the spatial information for me and started to map that. So what I want Insights to do is I want Insights to locate the information of my loan data. So this loan data has information within it regarding potential loans that were requested to this specific bank. So I have information such as the location of the potential loan recipient, whether that loan was accepted or not, what the loan amount was, the interest rate, and other information about this loan. So I want to relate this table that I just brought in with the demographic and socioeconomic variables of the community. So I'm going to start my analysis as a financial regulator. So first, what I'm going to do is I'm going to apply some cartographic techniques. I like to use a dark gray canvas. This really allows the data to pop out of the screen for me. And now I want to locate the location of the loan recipients or the potential loan recipients. So I need to enable location on this table. So enabling location is basically placing the dots on the map. So Insights for ArcGIS already looks into my data and sees you have latitude and longitude information. Would you like to enable location by that? And yes, I would. So now I want to add this into a map. I can do that simply by dragging and dropping this table into a new map. So now we have the location of all of these potential loans within DC from this theoretical bank. Now, information that I might want to view about this loan is whether these loans were accepted or denied. So if this bank was denying services in certain areas of DC. So just like in any web map that Rob showed you, I can change the symbology of this layer. So instead of looking at the location of these loans, I want to look at whether the loan was accepted or not denied. And I'm going to change the size of this so we can see it a little bit better. So now looking at the legend, I can see the loans that were denied, which are these orange dots, and also the loans that were accepted by this theoretical bank. We can also see the count of each of these categories. As mentioned before, Insights, it has the business intelligence feel to it. So I can also, instead of just creating maps, I can also create charts and tables. So one chart I might want to look at, we have multiple different types of charts that are available within Insights. But when looking at this disparity of accepted versus not, I might want to look at something like a donut chart. So this donut chart gives me a full circle of 100% of the loans and tells me the breakdown of the percentage which were not accepted and which were accepted. A really interesting thing about Insights for ArcGIS is that these visualizations are all linked. So if I click within this chart, in this card, the loans that were denied, the information in the map changes. It's a very interesting feel for visualizing this type of information, connecting information in multiple views. Another interesting capability within Insights is Insights searches for time and date fields. So we do have a date field in which these loans were either accepted or denied. So I'm going to drag and drop that into a new chart. So Insights automatically sees that what I'm looking at is date information, and it creates this time series map for me. So this time series map just tells me at what time were these loans accepted or denied. It doesn't tell me if they were accepted or denied, but I can group by any attribute within my table. So I can group by information such as the type of loan, whether that loan was a fixed rate loan, a secured loan, or an unsecured loan, or keeping along the lines of the same theme, whether this loan was accepted or denied. I can also create charts from multiple different types of variables within my data. So I can look to see what loans were accepted or denied, along with the interest rate of the potential loan, and create a chart out of that. So what is the average interest rate of the loans that were denied versus the loans that were accepted? One thing I might want to look at is the count of the loans accepted versus the loans denied. And I'll look at a column chart of that information. And I can also view the subgroup based off of, sorry. So now I've started to create this analysis as a financial regulator. I'm starting to get a better idea of the understanding of what loans and what services were accepted or what services were denied in certain areas. By doing the simple eye test, I can see that the loans that are being denied are mostly in East and South DC, whereas the loans that were accepted are generally in North and West DC. So I wanted to kind of connect these two dots. So what I want to do is I want to create some new data. So I can do that by what's called geo-enrichment. So I can bring in my tract information, and I'm going to filter all of the census tracts in the United States by just the ones that are in DC. So I'm going to look at just the census tracts in DC, and I'm going to drag and drop that on the map. Now, as you can see, I can add in multiple layers within these maps in Insights. I can also filter by certain layers or do spatial aggregations, which we will see later. So I'm going to add this layer in as a new map. And now I want this layer, these census tracts, to tell me some sort of demographic information. Within Insights, we do have what's called the action button. This allows you to open up the tools that are available within Insights. So one thing I might want to do is enrich this information. I can enrich the census tracts based off of Esri demographics. So Esri demographic powers the ArcGIS platform with a comprehensive set of demographic and socioeconomic data, including population, income, housing, consumer behavior, and more, used for mapping and analysis purposes. So as a financial regulator, I want to look at some sort of income levels for DC, and I want to relate that to whether these loans were being accepted or denied. So looking into the category of income, I can see that I have the 2017 median household income as a variable. I'm going to append that onto the census tracts and click Run. So now I have a new layer within this map, and I can symbolize by that specific layer. So we can see that one of the options to style by is the 2017 median household income. I'm going to change the symbology type to counts and amounts by color and update the symbology to see areas above and below the average. So as we can see here, looking at the legend of this new layer, we can see that green areas are areas of much lower median household income compared to the average of DC, and purple areas indicate a much higher median household income. So I want to relate these two layers together. I want to relate whether these loans were being accepted or denied in these areas of high and low income. So what I can do is I'm going to create a new map, and I'm going to run a simple analysis on this. And what I'm going to do is I'm going to bring in my loan information into the census tracts and combine the two. So when I drag and drop my DC loan, I can do a spatial aggregation. So what this allows me to do is this allows me to place the information within my table that I brought in and compare that to information within the census tracts. I'm going to add in an additional field, and that additional field is going to be the acceptance rate for these specific loans, and I'm going to choose the average. So now looking at this information, what I can see is the number of loans being written in each specific census tract. I can also change the symbology to visualize the average acceptance rate. But what I want to do is I want to relate these two. So I'm going to look at the 2017 median household income. I'm going to use counts and amounts. And I'm going to create a new chart. So my new chart is going to relate 2017 median household income with the count of average acceptance rate. So I'm going to use 2017 median household income and average acceptance rate and create a new chart. So this new chart is going to give me a flow chart based off of the average acceptance rate for each of these census tracts versus the median household income. So what we're seeing here is points at the bottom of this chart indicates a very low acceptance rates for these specific census tracts, and points at the top of this chart indicate areas of very high acceptance rate. Points to the left of this chart indicate a low median household income versus points at the right mean a very high median household income. Insights also allows me to add in regression models. So if I view a linear regression onto this, I can see that the regression is increasing as the average acceptance rate is increasing as the median household income is increasing. So looking at some of these areas that are below this regression model, I can see that these areas are in the lower income areas of DC that also have a very low acceptance rate. So simply by using Insights for ArcGIS as a financial regulator, I've been able to connect to my information of specific loan types from a financial institution. I've been able to create charts and maps to show where services were accepted and denied, and relate that to the socioeconomic and demographic information of these areas, simply by using Insights, to allow Insights to tell a story that this specific bank is not giving a normal distribution of loan acceptance throughout DC. So that is how I use Insights as a financial regulator. So back to you, Carl.
Okay, so our objective in this first workflow was just to kind of go over some of the basic and intermediate feature functionality of Insights. And what one of the takeaways there is, even though we did end up doing some complex things, the ability to use a tool as a non-GIS user, I think, is really what we want to show and emphasize here, where GIS does not have to remain, in the back room with the, with the highly technical employees. This gives agencies the ability to really extend pretty robust tools to folks that may never have used GIS before. So I think that's a really good thing to extend the, the software investment as well as the analytical capability further out throughout your organization. And it was done in one user interface, so you were able to link maps, charts, graphs, and tables, all that are dynamically connected in one small picture, which is really unique and really powerful. Now, the workflows were explained from an investigative enforcement standpoint. However, if you flip the coin on that, I would argue it is equal or even more valuable for maybe a commercial bank or institution to be able to do this types of analysis to prevent them from moving into or engaging into what might be perceived as redlining activity. So we're gonna move into our next presentation now, and it's going to be on the USDA's Food and Nutrition Services SNAP program, the Supplemental Nutrition Assistance Program. So when we say SNAP program, we're talking about a $70 billion a year program, and the task at hand here that we've put on to Patrick is, how do you find suspicious activity in a mountain of data? And we're going to ask Patrick to find what we'll call outliers or anomalies in the data that may be suspicious, but not, or may not be fraudulent, but worthy of a closer look. So he's going to start with national level data and filter and focus that down all the way to the state of Illinois, to a city, to Chicago, to a census tract in Chicago, all the way down to a specific store. So Patrick, I'll turn it back over to you now to go through that.
Okay, thank you, Carl. So as Carl mentioned, we're going to be looking at USDA's SNAP program. So SNAP, the Supplemental Nutrition Assistance Program, offers nutrition assistance to millions of eligible low-income individuals and families and provides economic benefits to the community. Food stamps or EBT cards can only be redeemed at stores that are verified retailers of the SNAP program. The SNAP program issues around $70 billion in benefits annually, which is available to be redeemed at approximately 250,000 stores across the United States. So a very large data set that we're looking at here. So USDA OIG is monitoring SNAP fraud in a multitude of different ways by reviewing SNAP retailer and participant transaction data using analytical and geospatial software to attempt to identify potential fraud. So within the SNAP program, one common illegal activity is what's called food stamp trafficking, which is carried out by a collaboration of SNAP recipients and SNAP retailers. So this activity is the redemption of food stamps by the retailer in exchange for cash. So the holder of the food stamp card receives cash from the retailer, and the retailer receives benefits from the federal government. So one example of this fraudulent activity was in 2016 of a DOJ investigation of the Upalaka Hialeah flea market near Miami, Florida, where the store owners had collectively received more than $13 million in federal payments for transactions that did not provide food. So I'm going to sit in the seat of an analyst investigating SNAP vendors using Insights for ArcGIS to analyze information to see if I can draw up potentially fraudulent vendors. And I'm going to, as Carl mentioned, I'm going to start out in a very broad area and work my way down to specific stores and small localities. So I've already started creating a workbook here within Insights, and I received some information. I received a table of information looking at the number of SNAP benefits received per state in 2016 and 2017. So I want to visualize this information. So what I need to do first is I need to spatially enable this, the same as we did on the Excel spreadsheet in the first example. And I'm going to use a geography. Now, using a geography, we'll take the state names and append them to our living atlas layer that we have here. And now I'm going to run this analysis. And now I can add this spreadsheet into a new map. So I'm going to blow this up for everybody. So now we have spatially enabled this new spreadsheet that I've received, and I can look at information such as the 2016 or the 2017 SNAP benefits. But what I really want to know is I really want to know what's changing within this landscape. So I want to run some analysis. So within Insights, in my action buttons, it gives me a list of commonly used tools such as creating distance buffers or drive times, spatial aggregations, enriching my data, a spatial filter, density analysis, and also routing analysis. But I can also use Insights to try to tell my story for me. So do I want to know how this information was distributed, related, what's nearby these locations, or how it's changed? So I want to know what's changing from 2016 to 2017. So I can calculate the percent change of the SNAP benefits received per state. I can give this a new field and click run. And Insights does this analysis for me. So now, looking at this analysis, instead of just looking at the 2016 or the 2017 benefits, I can look at the percent change of the amount received from the federal government by these states. So looking at changing this symbology, I can see using this map where the what states are increasing in the usage of the SNAP program and what states are decreasing. So I want to get a more granular look at this information. So I want to create a new chart, and I want to create a column chart. Move that up to the top. Now this column chart is telling me what states have been increasing and what states have percentages have been decreasing from 2016 to 2017. As you see, there's very few states that have increased in the usage of SNAP benefits, whereas most states have extremely declined. The state that has declined the most is the state of North Carolina, which has declined about 11% from 2016 to 2017 in SNAP usage. But I want to know what states are really affecting the budget. So I'm going to create another chart. I'm going to create another column chart, and I'm going to sort this column chart descending. So we have the states that have the highest amount of benefits received from the federal government on the left, and the states with the lowest amount on the right. So once again, connecting these locations, I can see that California has the largest amount of benefits being received from the SNAP program, but it has decreased from 2016 to 2017 almost 8%. So I want to look at these areas that have increased. So the biggest increase is the state of Alaska, but it has a very small amount of benefits. The third highest increase is the state of Montana, that also has a very small benefit receipt. Now the third highest percent change from 2016 to 2017 is the state of Illinois. It's also interesting to me that the state of Illinois is the 5th largest consumer of SNAP benefits in the United States. So I'm going to take a closer look at the state of Illinois. So as you can see here, I have already created a map, and what we're seeing here is we're seeing all of the locations of SNAP retailers in the state of Illinois. USDA publishes this information as a map service, which I have consumed through Insights for ArcGIS. Now we're doing some simple analysis. I want to look at the density. Where are most of these stores? It's pretty obvious to me where they're going to be. So I'm just going to run a simple heat map just to have the map tell me what I already know. So the highest density of SNAP stores is in the Chicago area. So I want to take a deeper dive to see if there's any possibly fraudulent activity happening there. So what I want to do is I want to bring in some county information and look at just Cook County. So I can create a filter on my Living Atlas layer, just looking at the state of Illinois and just looking at Cook County. I don't want to create a new map from that information. Now doing that filter, it filters out from all of the counties in the United States, just Cook County for me. So now I want to know what stores are within Cook County and work from that small subset. So what I'm going to do is I'm going to bring in my Illinois SNAP stores and add it as a new layer. So as we can see, we're populating the entire state of Illinois over the boundary of Cook County. And I want to run a spatial filter just to look at the Illinois SNAP stores that are within Cook County. So now that filter runs for me, and I want to create a simple map out of just this filtered information. Now these SNAP stores have information appended to them. These SNAP stores have information such as the average number of transactions for these stores per month over the last 12 months, and also the average redemption. So the amount being spent at these stores in the SNAP program, the average per month over the last year, as well as the store type. Now these stores, these stores have certain designations. So they have designations such as CS, which is convenience stores, FM, which is farmers markets, GS, which is grocery stores, PH, which is pharmacies, or SM, which is supermarkets. So supermarkets are the really large stores, your Walmarts, your Sam's Clubs. Your convenience stores are your, could be like a 7-Eleven or it could be a mom and pop shop. So there's multiple different designations of these specific stores. So from these stores, using this filter, I can see where exactly are my convenience stores, where are my grocery stores, where are my farmers markets, and so on. So what I've done now is I've filtered down my information just to look at the area that I'm concerned with. So now I want to learn more about the communities of Cook County and see if I can relate the community's demographics with any possibly fraudulent activity. So I've already done a spatial aggregation on census tracts for the SNAP stores to the census tracts in Cook County. And what I'm looking at here is I'm looking at all of these census tracts and the average redemption amount for each store within these census tracts. So the larger the dot indicates the census tracts with a high average redemption rate for all the stores, and a small dot indicates a low average redemption rate for all of the stores within each census tract. So now I want to learn more about the landscape of this area. So I want to run a geo-enrichment. Now, as an investigator, I don't know the plethora of data that's out there for me, so I kind of want to take a stab. I'm going to see if there's anything within this Esri curated content around SNAP. So I'm just going to take a stab in the dark and type in SNAP, and I have received some results. So one of the variables within this Esri demographics, this curated data set of about 65,000 plus variables, is the number of households receiving food stamps. And this is coming from the American Community Survey. So I'm going to append this onto my onto this layer, so I can compare and relate these two layers together. I'm quickly going to rename this data set to geo-enrich. I'm sorry, I accidentally deleted it. And I'm going to create a new map from this information. So now, using this new layer that I've created, I want to look at this new attribute. I want to look at the total household, or the number of households within each census tract that are receiving food stamps. I'm going to quickly change the symbology. Instead of looking at natural breaks, I want to look at equal interval. And I also want to change this symbology to possibly a green dot, a little bit of an outline. So now what I'm looking at is I'm looking at two different maps of the same area with my Illinois SNAP data. So the map on the left, I'm looking at the average redemption rate for census tracts, and the map on the right, I'm looking at the total number of households on food stamps within the city of Chicago. So information that I'm concerned about is the relation between these two. So once again, I'm going to create a scatter plot. Now what this scatter plot is telling me is that areas on the left of the scatter plot indicate census tracts that have a very low number of households within the SNAP program living in those census tracts, and dots on the top of this chart indicate census tracts that have a very high average redemption rate within them. So the first one I want to look at is this one here, this one at the top. This is an extreme outlier to me. It has a very low number of households in that census tract receiving SNAP benefits, but it has a very high average redemption rate. So I'm going to zoom in here and look at this location. I can see that this location is in downtown Chicago. So this is an area that is generally a higher income area, just outside of the loop, but it is a very busy place. There are a lot of jobs in this area. So I can assume as an investigator, from what I know, that this is an area that people commute to and travel through a lot. So this is a reasonable outlier in my opinion. The next location I want to look at is the second highest average redemption rate. Now looking at this map, this census tract is way out into the suburbs of Chicago. So that's very interesting to me. There's not a lot of number of households receiving food stamps in the census tract, but a very high average redemption rate. Almost the stores in this area, in this census tract, average about $15,000 a month, which is extremely high. So I want to take a deeper dive into this specific area. So I've already filtered out this area and filtered out the SNAP stores within this specific area. Now I want to look at these SNAP stores, and I want to look at the store types and also the store names of these specific stores. So I want to look at the store type with the average redemption rate, and I'll create a chart here. Let me create a column chart. So now what I'm looking at is I'm looking at the different store types within this area. So I can see my convenience stores, my grocery stores, and my supermarkets. As we can see, supermarkets have a high average redemption rate, which is very, very normal. I also want to look at these store names with the average redemption rate to see if I can find any kind of anomalies here. So I'm going to create another chart, a column chart, and I'm going to sort this. So one thing I can do within Insights that we've seen earlier is by creating a subgroup. So the subgroup I can create on the store types is the store name. So now looking at this, I'm seeing an extreme outlier here. So all of these vertical bars here indicate specific stores within these attributes. So the specific supermarkets. So here what we have is we have a Walmart that has the highest average redemption rate. We also have our grocery stores. So another supermarket is the Aiden supermarket. That has the third highest redemption rate. But this store here, this is a convenience store. Now this convenience store is doing more business within the SNAP program than this supermarket. So this supermarket is charging an average of $35,000 to the federal government, where this convenience store, One Stop Shop, is charging $41,000, just less than the Walmart right down the street. So that is an extreme outlier to me. This is it seems like a small store with an extremely high redemption rate. So it could be a known location where people take their food stamps and traffic their food stamps at this location. So I can assume that this location needs further investigation. So what I've done here is I've used Insights for ArcGIS to start at a very broad area to try to burn down that haystack and find my outliers using Insights analytics analysis. Back to you, Carl.
Okay, so a couple of things. Just a quick reminder: you guys are able to ask questions through the online tool. So if you have questions, just hop onto the GoToWebinar window and type in your questions, and we'll get to them at the end of the webinar. Again, so our workflows may not be 100% matched to yours, but take into account how how Patrick was able to slice and dice data from massive data sets all the way down to, you know, a street block, right, in the city of Chicago. And think about the questions you have and fit them into the questions, and I think you'll be able to do very similar things. So we did show some complex workflows through here, and we identified geographies and locations with high redemption rates, yet were in areas with low amounts of households. And really quickly, you know, Patrick identified a example that made total sense, the Walmart example, you know, a big corporation that should have high volume activity. But he also, in a matter of minutes, identified something that didn't make sense, which was the convenience store, the mom and pop one-stop shop that potentially was doing inordinate amounts of activity that, again, may or may not be fraudulent, but certainly worthy of additional review. So our final, we have about 10 minutes, so we're going to go through this last one pretty quick. Our final workflow is going to be part analysis, again in insights, but part information product dissemination. And we're going to focus on healthcare fraud within the Medicare Part D program, which is what you would generally associate with painkillers and, again, opioids. We talked about that earlier. So Patrick's going to first identify suspicious activity through insights, and it's going to be very tactical and investigative based at a specific doctor level. But then he's going to actually show how you can report out the results of your analysis or your information products to a broader audience through story maps, and share that in many different ways, internally within your organization, or you could even, if you so chose, share those story maps externally to other parties that you wanted to share that with. The key here is I want you to pay special attention to what we'll call tradecraft. So Patrick is going to go through some workflows. He's going to create models of those workflows and save them. He's actually going to save that tradecraft, and that model, that tradecraft, is going to be usable to other people within the agency or in your organization. So if you are a national level agency assigned to a Miami field office, and you come up with an interesting tradecraft, you can actually save that model, put it in an area where other people can get it. Again, you know, these are standard national data sets, so often your data sets will be similar. Somebody in Miami creates an example, and then somebody in New York City or in Los Angeles investigating similar things can literally leverage that model and do the exact same thing, saving tons of time and a ton of resources. So Patrick, I'll throw it back to you.
Okay, thank you, Carl. So as Carl mentioned with this last demonstration, we want to show you the ability to record and rerun your insights workflows and communicate the results. So for this specific workflow, we're going to be looking at healthcare fraud within Medicare Part D. And I'm going to be sitting in the role as an HHS investigator to analyze prescriptions written by specific physicians. So what I'm going to do is I'm going to start with the insights, and I'm going to assume something. I'm going to assume that a tip came in from our tip line about a physician in Denver, Colorado. So I'm going to map the location of that physician in Denver, Colorado, and with the resources that I have as an investigator, I also have access to the location of the prescriptions that this physician is prescribing. So zooming out of this map, I can see the spatial disparity of these Part D prescriptions written by this specific physician. I can see that something is already sort of an anomaly. I can see that this physician in Denver, Colorado is writing prescriptions mainly around Denver, but also in Florida and Arizona and in Southern California. But as an investigator, I know that this is not an extreme anomaly. There's a term called snowbirds that people, especially in colder climates, will retire in southern states, but will keep their same physician, whether they've been with them for a long time, they feel comfortable with them, they visit home, they visit Denver very often. So there's a reasonable response to this sort of anomaly. So what I want to do is I want to get a better look at this, because I see a very, very large population around Denver, Colorado. So what I'm going to do is I'm just going to do a simple spatial aggregation of these of these prescriptions being written to a county level. And while that's running, I also want to look at this information in another way. So what's really important to me is the drug type. So within Medicare Part D, there are various different drug types that are available, and some of them are being abused more than others. So I'm going to style this information by the product name of the Medicare Part D, and I want to look at the dispersion of this drug type. So I'm going to create a new chart, and I want to create something that I don't think I've done today yet, is a tree map. So this tree map, as you can see, the colors of this tree map are also reflected in the map. The tree map indicates the number of prescriptions being written for each of these specific drugs. So lidocaine is something that interests me. So lidocaine is one of the most commonly used local anesthetics used for adulteration of illicit cocaine. So that comes across the table already as being possibly fraudulent. Now, what I want to do here is I want to look at the prescriptions and when this physician was prescribing them. So I'm going to use my date field and create a time series, and I'm going to group by the medical product. So here we can see the number of prescriptions being written within specific time frames of the past about 2.5 years. So we can see from October 23rd to October 30th, 2016, this physician wrote 49 prescriptions for lidocaine. That's a very high amount for me. I want to also create another time series. Instead of looking at the number of prescriptions being written by the drug type, I want to look at the total that is being charged to Medicare. So I can use my my attribute of the total amount being charged. So for the same week, 49 prescriptions of lidocaine, that totaled about $68,000 being charged to Medicare. I can also create tables of this information. So here I'm going to create a simple table of the drug type and the summation of the numbers of prescriptions being written, and I can also do the same for the total amount being paid for the specific drug types and create a new table. So looking at this information, I can see that this physician is writing a very high level number of lidocaine prescriptions, but it seems to be over a pretty normal spatial and a pretty small spatial disparity, but over a very large timeline. So this is not absolutely fraudulent activity to me. But what I do like is I like this worksheet that I created. I believe that this can be used for physicians all across the United States. So if I want to share this workflow with someone, I can. What Insights is incredible at is Insights tracks your movements. So as you can see here, Insights has created this model to walk through the steps of the algorithm that I created, that I use to create my worksheet that I have currently. So as you can see, I've brought in my multiple data. I've located that data. I've styled it. I've done some spatial aggregations. I've created tree charts. I've created time series. So all of this information can be shared with others. So what I need to do is I need to share this as a model. So this can be used across HHS. So I'm going to share this as HHS model. I'm going to give it a quick description of fraudulent physician, and I'm going to share this with everybody within my organization. So now this model is shared and can be rerun on similar data sets. So I have another tip line coming in. This tip line is coming in looking at a physician in New York City. So I have connected to my data. I'm going to add in some more data. I'm going to add in the Part D prescriptions by this specific physician. And I'm also going to add in my model. So I've just created this HHS model right here. So I'm going to add in this model to this worksheet. So as you can see, once I add in that model, it goes ahead and populates where I have all of my pages, or where I have all of my cards within my page, but it doesn't populate it because the data is not connected yet. So if I go into my model view, I can go ahead and update this information. So I can update the location of where my counties are, update the physical location of this physician, and also update the table that I want to use to run against this model. I can go down here to make sure that my fields have stayed the same, and then I can update this information. So as you can see, while this is updating, this model is already starting to churn for me. So it's already doing the spatial aggregations and creating these time series charts. So once I go back into my page view, I can see, boom, that this same model has been applied to a brand new data set. Now, this all of a sudden jumps off the page for me because I can see an extreme amount of lidocaine prescriptions being written. I can see a very large a very large area that these prescriptions are being written. So this physician is traveling to Buffalo, Rochester, New York, through Pennsylvania, all the way down to North and South Carolina, and even Louisiana. So this information is extremely valuable to me. So within this 1 week period, I can see that this physician wrote 87 lidocaine prescriptions from December 4th to December 11th, all throughout the state of New York. That information, those prescriptions totaled to be $115,000 being charged to Medicare. I think that this is absolutely fraudulent activity, and I want to share this with others within my organization and with leadership. So what I can do is I can share this page from Insights. So I'm going to share this page. I can give it a name and a short description, and I can determine who I want to share it with. Do I want to share it with the public? Do I want to share it with just users within my portal, or do I want to share it within specific groups like Rob Fierstein showed us earlier? So I'm going to share this page, and I can share this page in multiple ways. So I can just have a URL where someone can go to that URL and open this Insights worksheet that we see here, or I can also use an embedded iframe. So an iframe can be placed in the HTML code of any web page. So this Insights worksheet can be shared embedded into a web page. But what I've done is I've started to create what's called a story map. So story maps are simple yet powerful ways to inform, engage, and inspire people with any story that you want to tell that involves maps, places, locations, and geography. So they make it fun. They make it easy and fun for you to harness the power of maps to tell your story. So for this specific story, I'm telling the story of how we got to this investigation. So we began the investigation with a tip line, we gathered our data, and we've explored that data. So I'm going to add in a new section here, and I'm going to add the media as this iframe. Now what this will do is this will place that Insights page within this story map. So if I view the finished story map, I'll save this and view my finished story map. This is what I can send to leadership or send to others within my organization. This is a great way to tell a story. So I'm telling the story of investigating a suspicious physician in New York City. I'm telling a story of how I began my investigation, how I gathered my information, and what I did with data exploration. So using Insights, I've been able to create this analysis. Now, this is not just a static screenshot. This is still a dynamic worksheet that you can still go into deep dives into the data within this. Now, through the story map, I also talk about the conclusion. So based off of my conclusion, I can conclude that this physician is acting in a very fraudulent manner and should be investigated more thoroughly. So that is how I can use Insights for ArcGIS to record and rerun my workflows. So these processes don't have to be iterative. They can be completely automated. I also used Insights to share information out to my organization and to leadership using story maps and the ability to share our Insights pages. So that is how I used Insights sitting in the role of an HHS investigator. And that is the conclusion of our demonstration. So back to you, Carl.
All right, great, Patrick. So if you want to go down to the question slide, and as you're doing that, just a couple quick summary comments. So identifying fraud when it comes to the opioid problem is really different. So in this scenario, the fraudulent activity, I think you could absolutely link to the loss of life through ODs, which is a really different scenario than a lot of the fraud conversations that we have. We could also argue that it links to the use of illegal drugs and even crime and violence associated with with that supply chain, the possession, sale, and distribution of drugs, because once you can no longer get your pills from the doctor, you're going to get it from the street, and then the issues with heroin and fentanyl overdoses become a significant issue. We went through the standard analytical tactics in all three of these demonstrations. This last one was a bit different because we showed you, one, the ability to model and share your tradecraft, and two, the ability to demonstrate or disseminate some of the things that were learned in an investigation. That could be used for an internal briefing, after action reports. You could even release it to the media and have them embed that in one of their websites to their websites at their locations, if that was something you're interested in. But let's hit. We've got just a couple questions. I think the first one will go to Patrick. Can you talk generally about the learning curve and what it takes to acquire a working knowledge of Insights versus a working knowledge of desktop?
Oh, well, that's an interesting question. Insights is as I've mentioned before, is our new analytical tool. It is unlike most of the tools that we currently have, but the functionality is incredibly easy to learn. As you saw from my demonstrations, a lot was dragging and dropping, a lot was just selecting what I wanted to view and how I wanted to view it. And running the analysis tools is very simple using Insights. They're all wizard-driven analysis, whereas desktop analysis does provide more powerful analytical capabilities. It is a little bit more intimidating. I think that the learning curve there is a little bit easier with Insights compared to desktop, especially for new users, whereas experienced desktop users would be able to come into Insights if they're either a desktop or a ArcGIS Online portal user, come into Insights seamlessly and be able to create their analysis and their worksheets. Yeah, that's.
Okay, great. Our second question, are there other types of story map templates that are available to users?
Oh, sure. So the story map that I used was a story map template, story map cascade. As you can see, it's a very easy to create and edit functionality. If you visit our story maps page, storymaps.arcgis.com, I use this all the time to see what's new and how people are using story maps to tell their stories. There's a couple of things on here that showcase the different types of story maps that we have. Story map swipe series, story map tours, story map journals. Each of these templates are designed to tell your narrative in a specific way. They're very, very interesting to work with. Combining your mapping information with your other multimedia to create your narrative to tell a story. So I would suggest people visit the Story Maps website and also peruse through the gallery to see what other people are creating out there in the public. It's very, very interesting content.
All right, I think we're only going to do one more question here, but I think that this one's kind of important. So I'm a current customer. How do I get Insights, and is it extra? So I'll handle that one, Patrick, I think. And so Insights is a premium app, and it's available in 10.5 that works with your level 2 named users. Now, there's a couple different options. I think the easiest way up front for I think 3 options that I'll outline are talk with your account manager. That's always the best way. So it may already be part of your organization if you have an ELA, so I would check that one out first. The second option is you can purchase Insights up to the total number of level 2 named users that you currently have, and again, just contact your account manager. There's also a website that you can go to, go.esri.com/insights-offer. Again, we'll provide that, we can provide that URL as well as the other that I discussed in a follow-up email. So you don't have to memorize what I just said. And there's a third way that you can do it too, and that is through managed services. So there is an Esri offering in our managed cloud services where you can actually procure insights, and that is if you want to do the types of data analytics, data exploration, interrogation that we showed you, but you don't want to or you cannot manage the infrastructure to do so. That's why those are the scenarios where I would turn to a managed services type of offering. So that concludes our webinar today. We're a couple minutes over. Thanks for your patience. Thanks for your participation. If you have any questions that you have directly right now, there's two email addresses on the bottom of our question screen. You're welcome to contact myself or Marcelo. And again, we'll also follow up with some informative information through an email that will go out to all registered attendees. Thanks. Have a great day.